Okay, fine. I'm repeating again. I'm repeating
Okay, sir.
lapping.
Okay.
So this
Thank
is
you,
nothing
sir.
but I'm taking a glimpses of last class, whatever we're discussing about lapping process. So in lapping process, what we are doing, we used to have a loose abrasive particles. So in this image, if you see, so this is a workpiece. Whatever the bottom portion is a workpiece. So on this workpiece, we are sprinkling. So loose piece of abrasive particles sprinkling on the workpiece surface. After sprinkling, so this is the lap tool. So on this abrasive particle, we are rotating the abrasive tool. When you're rotating the abrasive tool, what happened? The abrasive tool will carry. It is used to carry these abrasive particles along with that. So if you see in this next slide, so this is a typical your lapping tool. So lapping tool is look like this. So I told you it's similar to your scrubber. So scrubber, you know where it is using scrubber in your home?
बर्तन धोते सर,
बर्तन धोते, राइट? बर्तन धोने की घसनी ऐसी घसनी बोलते हैं ना उसको. सो बर्तन धोने की
हाँ
घसनी
सर,
बोलो या फिर स्क्रबर बोलो, ऐसी रहता. क्या करते हैं इसमें? अपन साबुन लगा के, विम है या फिर विम जेल हो, इसको लगा के बर्तनों को मांजते. मांजे तो क्या होता है, बर्तनों में जो भी कुछ खराबी रही या फिर कुछ लगे हुआ रहे तो निकल जाता, राइट? लैपिंग भी
Yes,
सेम
sir.
है. वहां बर्तना मांज रहे, यहाँ पर वर्कपीस को मांजना है और कुछ भी नहीं है. मांजे तो क्या होता है, बर्तन साफ चमकता हुआ दिखता ना. यहाँ भी वैसी है.
Yes.
इसको सुपर फिनिशिंग ऑपरेशन बोलते. So your surface is looking like very luster and surface roughness is reduces and it is looking very good surface finish. तो यही लैपिंग का यही प्रोसेस है. आप घर घर जो बर्तना मानने का काम ही है इसका. हम बर्तना मान रहे हैं, हम बर्तना नहीं है, सरफेस वर्कपीस को मान रहे. मानना है, मानने का मतलब है कि सुपर फिनिशिंग ऑपरेशन. तो सेम थिंग. तो इन बिटवीन यू यूज टू हैव द विम जेल या फिर विम का कुछ जो भी साबुन का जो भी लगाते हैं ना, वो साबुन की जगह यहाँ पर क्या अब्रेसिव पार्टिकल्स लगा रहे. तो अब्रेसिव पार्टिकल स्प्रिंकल कर दे रहे, राइट? उसके ऊपर से आप ये लगा रहे, बस ये लगा के इसको मान रहे. सो दिस प्रोसेस इज कॉल्ड एज अ लैपिंग प्रोसेस. सेम थिंग. So this is very small in size. Maybe if you want to see, maybe hardly 10 centimeter size. So this is in manual lapping. So same thing, whatever you are doing in the kitchen, same thing we are applying. So वहां पर जो करते हैं वो स्क्रबर रहता, सॉफ्ट प्लास्टिक का या फिर रबर का रहता या फिर कपड़े का रहता. तो जो हम वर्कपीस, क्योंकि वर्कपीस इज वेरी हार्ड मटेरियल, दैट्स व्हाई नॉर्मली वी आर यूजिंग फॉर मेटल स्क्रबर हियर. So remember, lapping tool is nothing but it is a metal scrubber. So यहाँ पर ऐसा rough face रहता. So the rough face में whatever the abrasive particles you have seen previously, so these abrasive particles are holding in this. So whatever you are seeing rough surfaces, these rough surfaces holding the abrasive particles. When you moving this, so this has to be doing upside down. So when you doing upside down, in base you having a workpiece. So this is a workpiece and this is the lapping tool. जो rough surface है ऊपर का दिख रहा है वो यहाँ पर है. तो उसके जो गैप्स आ रहे हैं, सो वो गैप्स में ऐसे abrasive particles will going to stick in this. So when you moving your this lap tool, so along with the tool your abrasive particles are moving. Abrasive particles are very strong. Already you have seen in your grinding. In this abrasive particles, so this whatever the strong abrasive particle, when it is moving forward and backward, so this is removing very small layer of material. So this very small layer of material is removing. The same thing. This is called lapping. So lap is the use to cut harder material. Normally this is using to cut not for the soft material. Soft material के लिए lapping normally use नहीं करते, क्योंकि whatever the abrasive particles are there, it's very strong. So if you're using soft material like aluminum, what happened? So these material, this whatever the hard particles is going and penetrating into the material. Instead of making a smooth, it is making some kind of holes. So that's why we're not using for soft material. Normally this lapping is using for hard material like cast iron, tungsten, these kind of material we're using. So very fine limit of material is removing, taken to finer limit. So this will produce a polished surface, such as polishing cloth, right? So कपड़ों से जैसे polishing करते हैं उस तरीके का polishing हो जाता है metal पे. Very smooth surface you're going to get, specially for harder material, not for the softer material. So taken to ultimate limit with the aid of accurate interferometer. Even interferometer is one equipment which is used to measure the surface roughness, that maybe we can discuss about in metrology in your next chapter. So in that also, if you measure surface roughness is very small in this. So very smooth surface you're going to get by using this process, lapping. So in lapping, we having hand lapping as well as a machine lapping. I hope this we discussed in the last class. So hand lapping, nothing, whatever I explained to you, it's hand lapping only. You sprinkle the abrasive particles and just rubbing the lapping tool. So we are using with the hand. That's why I used to call it as a hand lapping. So this, in addition to hand lapping, if you want to increase the process and where you want to remove wherever the very strong material is there whatever the manual force sometimes is not sufficient. So we need to have a machine force is required, as well as we need to increase the process. So for that we need to go for machining lapping. So manual lapping and machining lapping is same. Only manual lapping in manually you're doing. That's why your speed is less. Here you're doing with machine. So that's why here speed is faster. Because of faster speed, your process will be faster. So whatever the manual lapping, if you're doing in 1 hour, so this will complete within 1 minute. So that much accuracy, that much fastness is coming. So when we are doing in industrial purposes, we need to manufacture component in very fast, right? In 1 day we need to manufacture, in 1 hour we need to manufacture a lot of components. So normally in industries they're using the machine lapping. So in machine lapping, what happened, you having a rotating table you used to place in plate. So there is a rotating table is there. So on this rotating table you used to keep your workpiece, and that you having a top portion as well as a bottom portion. So top portion is this whatever the lapping tool is there. This is your workpiece is, most of the cases workpiece is stationary, and your top tool and bottom tool, whatever the lower lap as well as upper lap, used to rotate about its axis. Then whenever there is a relative motion is coming between the lapping tool and your workpiece. So because of this relative motion, so it's applying some kind of force on this and removing. Even sometimes what happened, your workpiece is rotating in opposite direction to your the movement of this lap. So in that case, what happened, relative motion is increases further. So your machining process is increasing. So wherever we required very fast machining, then in that case we used to have the rotational motion in both for lapping tool as well as the workpiece. So they both are in opposite direction. They're rotating about opposite direction. So this is the typical machine lapping. So this is also I've shown you last class. In that, even sometimes what happened, because if you sprinkle your whatever the workpiece, normally in machine lapping is not possible to continuously you can feed abrasive particles. So in that case, what we used to have, we used to make abrasive in the form of a slurry, mixing with some kind of liquids. So dense liquids we used to mix it. So these semi-solid whatever is there, which is consisting of abrasive particle. So these abrasive stream, I can call it as a stream. So this abrasive stream is allowed to pass between the abrasive tool and the workpiece. So you see here is a wheel rotating and this is the workpieces. So in between it, when it is passing, your workpiece is going to be very smoothly machined, and it is going to machine very fast, and in less time you're completing your object. So this is a typical machine lapping. So one more thing is that this is for bigger components. Normally we're using this. The same kind of equipment setup in the lab. It look like this. So it's very small, like our maybe in your polishing machine. I told you last class. So this is nothing but your like just like your polishing machine. So in this is the manual lapping machine. So maybe these are the holder. So in that you can keep your workpiece and you can run this when you're running. So inside whatever the lapping tools are there, it is rotating and it used to remove the whatever the surface layer. So lapping can be used to obtain a specific surface roughness. So normally when your two mating components are there, when especially when slip gauges, when any measuring equipment, then contacting surfaces has to have very smooth. So those kind of smoothness is going to get by this kind of machining process. So mostly lapping is using for hard material. Remember, not for the soft material. So then coming to be honing, I think this is already I explained to you. Now going to be honing. So honing and lapping is almost similar kind of process. There is not much difference. Only difference in honing, normally we are not using any loose abrasive particle. Instead of using a loose abrasive particle, we are using a kind of honing tools, honing sticks we used to call. So this is a typical honing operation. So in this previously, whatever the lapping is there, so lapping normally we are using for flat surfaces, right? So to make any flat surface, but normally that kind of arrangement may not possible to machine on the circular object, especially for a kind of holes when you're making drilling a hole. To finishing that hole is not possible to do by lapping. So for that, normally they used to have this kind of honing. So in this, whatever this is there, this is nothing but your honing tool. So like lapping tool, there is a honing tool is there. So in honing tool, normally we are not sprinkling the abrasive particles, but to this honing tool, there is a impingement of particles or impingement of abrasive particles. Abrasive particles are embedded into this one. So like maybe you can see in your bread, maybe some kind of sweetness is embedded into the bread. So similar way, so here in the stick, a metallic stick, in this metallic stick, so your abrasive particles are embedded. So this embedment is similar to your grinding wheel. So grinding wheel is a wheel, it's a circular, but your honing tools are like a rectangular sticks. So that's why this used to call the honing sticks, are nothing but honing stone also. Sometimes if it is a heavy, we used to call it as a stone. If it is a thin in size, we used to call it as a honing sticks. So these honing sticks are mounted on a tool. So this is a machine. You can call it as a honing machine or nothing but honing tool. So on this, these honing sticks are nothing but honing tools are mounted, and this is rotating about its axis. When it is rotating, because this used to have very abrasive, fine abrasive particles are very hard and very sharp. So these abrasive particle when is down, so maybe these whatever the honing tool, honing machine, it can reciprocate into this. So this is a opening hole. So in this it can reciprocate when you moving down, and in this if it is rotate, so whenever this whatever the sharp particles coming in contact with this whatever the surface inside the surface, then what happened if any kind of projections are there, very small minute projections, if anything is there on the surface, so the surface minute projections or minute material is going to remove. So this process is called as a honing process. So in this abrasive machining process that produces a precision surface on a metal workpiece by scrubbing. So this also is similar to scrubbing process, an abrasive stone against it along a controlled path. So here whatever is there, so this is following a path. So in this path, when it is controlled speed is moving, so these whatever the work pieces are, whatever these sticks or stones are there, so these stones removing the unwanted material. So normally this is used for holes. Most of the holes which is already drilled by drilling machine, and after that enlarged by boring machine. So later, after boring is completed, boring is nothing but enlarging the hole. So after enlarge the hole to the required size, then we need to have finish the hole, because in hole normally if it is take the in engine, so normally we used to have a piston. So piston used to have some standard size of the hole is there. So in that piston, the cylinder, sorry, not piston, cylinder. So in that cylinder, whatever the hole is there in the cylinders, in that cylinder, piston has to move, right? So when piston cylinder is moving, so above that you used to have some kind of combustion is taking place. If these two surfaces, cylinder and piston, is not properly meeting or not properly contacting, what happened? There is a clearance, there is a gap is happening between this piston and cylinder. So from this gap, whatever your combusted gases, which is at higher pressure, can easily escape. To prevent that, what we used to have very smooth surface between the cylinder and piston. So with this, in between these smooth surface, there is no air gap has to be there. So for that, we used to have very smooth surfaces required. So for that, we are using this honing. So honing normally using for circular object, especially for making the holes, finishing of holes. So finishing once hole is prepared by the boring machine. So after that, this honing tool is inserted. So into that hole. So like this, whatever the hole is there, inserted in that, and this honing tool is rotating about its axis. When it's rotating, so this workpiece is stationary and tool is rotating. So what happened? Whatever the unwanted projections are there on the surface, so those unwanted projections are removing. So normally 6 to 8 honing sticks used to connect on the periphery of this honing tool. So sticks are held together and metal is removed by rotating or reciprocating, rotating and reciprocating. What happened if it is a very small in depth? So only rotation is sufficient. But this whole length is very long. Then whatever the stick length is not sufficient to cover entire length. Then what happened? So you need to continue the rotate as well as you need to reciprocate these tools. So reciprocate in this direction, forward and backward, as well as rotate about its axis. So in this normally for our lapping process, we used to use for normally dry, but special cases we are using the wet lapping. But in honing, normally we using for wet only. So honing tool normally used to cutting the wet cutting process. Used to have some kind of some kind of what we can coolants is required, some kind of lubricants is required. So those lubricant particles, what they used to do, they used to dry out whatever the material removal is happening, whatever the chips are coming out, very small size of the chips, whatever the coming out from the workpiece. So those chips has to be removed. So that's why normally this process, normally honing is happening with wet cutting process. So honing tool is rotate at a speed of 0.5 to 2.5 meters per second. So it's rotating very not very slow speed, at the same time not very high speed. It is normally rotating at some moderate speed, 0.5 meters in 0.5 to 2.5 meters rotation they're doing in 1 second. And if it is going to take the reciprocation speed is normally is less, because it's in reciprocate normally after rotary is completed at a particular location, then it has to move into the next location. So that's why normally reciprocating speed is lesser, but rotary speed is a faster. So most hardening is done on the internal cylindrical surfaces such as automobile cylindrical walls. So most of the cases, these hardening tools are using to finish or nothing but to super finish the internal circular surfaces. So like whatever the surface you see. So normally for flat surfaces or maybe external surfaces, normally we using to use lapping, and for this we use hardening process. So hardening was a typical application. Maybe you can see this is also a typical hardening tool. So in this, maybe you can see this is the holder. So in this is the holder, and this is this attachment is there. To this, you used to stick this hardening sticks or hardening stone. So this hardening stone, and this is inserted into a check. And when this is rotates, so this setup is rotates. What happened? So this whatever the hardening sticks is there, this also rotates. When it is rotating inside a circular object, so then whatever the surface is coming in contact with these sticks, so that circular surfaces it is to remove. So here the maximum thickness of the layer can be removed is less than 0.05 mm. That is nothing but 50 micron. So typical applications of the finishing of cylindrical internal combustion engine, air bearing cylinder and gears. So this kind of finish, wherever gas tight or gas proof joints are required, there normally they used to use this hardening operation. So these are many types of hardening, but all consisting of one or more abrasive stones that are held under pressure against the surface they are working on. So in that, so maybe you having a spring force is there. So these whatever the sticks are there are nothing but stones, hardening stones. So these hardening stones are pressed against the internal surfaces, nothing but internal holes of a particular object, a particular workpiece. So normally this is hardening is using for internal surfaces, right? So in that internal surface, you need to hold it. So this whatever the tool you're seeing, so these tools has to be keep inside the hole and it is rotating. So in terms of sharpening knives, hardening steel does not actually hone the knives. So normally for knives and these things, normally we used to call it as a honing, but actually those process is nothing but it is a lapping process, because knives are all the flat surfaces. So these flat surfaces, super finishing operation is performed by lapping, not by handing. So other similar processes are lapping and surface finishing. Most of the, even some special cases, surface finishing operations also can be performed by these hardening tools. But most of the cases, predominantly hardening is using to finish the internal circular holes, not for the external, not for the flat surfaces. So hardening stones are made from the common abrasive and bonding material. So normal, whatever the hardening stones you've seen. So this hardening stone is a little different than lapping stone. So lapping tool, whatever you've seen, there only you having a hard metal rectangular pieces are there with some kind of circular roughness is there in that. But here, so in this hardening tool, it is just similar to your grinding wheel. So what happened? It used to have some kind of bonding material is required. So this bonding material holding the abrasive particle in the form of a rectangle. So in hardening stones are rectangle, similar to the grinding wheels. So grinding wheels are circular, but hardening tools are the rectangular kind of a bars will be there. So rectangular kind of stones, or maybe you can call it as the sticks. So made from the common abrasive and bonding material. So often impregnate with the sulfur, resin or wax to improve the cutting action and tool life. Normally it is adding with means in that whatever the bonding agent is there, so in that bonding agents normally use sulfur. So mixed with sulfur they used to add, and also they used to have resin or wax. So normally for polythene, whatever the plastic resins are there, those resins also can use to hold these abrasive particles. So these by providing the sulfur and other abrasive other mediums, what happened? They will increase your cutting action of these hardening tools. So abrasive particle must withstand the cutting pressure for metal removal. So what happened? So in previous case in lapping, you used to have the free abrasive particles are there. Whenever it's wear out, it can run out from its position. But here, so these abrasive particles are embedded into a metallic object. So here, so these abrasive particles must withstand the cutting pressure very high. So when you're cutting the material. So bond must be strong enough to hold the grit. So whatever the bonding we're using, whether it's using a sulfur medium or maybe wax or resin, so this has to have sufficiently strength is required so that it can prevent the wearing out of the abrasive particles frequently. So not so hard as to rub the bore and retard the cutting. So it's normally because we are using some kind of resins. So here these the hardening sticks are not strong as your previous lapping tools. So just give me 1 minute. I'm getting some important call. I will take up the call. Okay, I'll resume that. Okay. So abrasive, normally whatever the abrasive sticks, so whatever the abrasive things are there, so these abrasive things are normally using to be very hard material, not for soft material. And these abrasive sticks, whatever is there, for this honing, normally they used to have very soft, little bit softer compared with other things, whatever you have seen previously lapping. So bond must be strong enough to hold the grit, not so hard because it used to have some kind of polymers and resins. So this process is simultaneously rotates and reciprocates. As I shown you in the previous graph, this used to have a rotational as well as a reciprocating motion is there. So maybe just give me some time. Okay, simultaneously rotating and reciprocating motion is there, whereas in previously it's only a reciprocating and only rubbing action is there. The surface producers will have a characteristic scratch hashed lay pattern, some kind of, because you have very fine abrasive particles are there. If you microscopically, if you observe, you can find some kind of star pattern you can observe on the surface. So this star pattern, the thickness is less than micron, 1 micron. So normally with your naked eye, maybe you cannot see. So maybe you can see it's very smooth surface. Even you cannot feel with your finger also, because it's very minute, less than micron. So that's why you cannot see. But if you observe under microscope, maybe you can see some kind of hatching on it. So this is a typical honing tool. So it's this is the honing to stick holder, right? And these are the honing sticks, are nothing but honing stones. So these honing stones are rotating about its axis, and these are the workpiece. So maybe inside, maybe you can assume it is a cylinder. So IC engine cylinder. So in this it is rotating. So when it is rotating about its axis, so the rotating and as well as the reciprocating, when it is rotating, this whatever the sharp edges are there, so these sharp edges in coming in contact with the surface of the workpiece, and it is removing the material from this. So very small material, whatever the thickness, maybe one micron to 3 micron, or maybe maximum 10 micron thickness of the material can possible to remove by this action. And this action, because surface is very smooth, so very good surface roughness and very good surface finish you're going to get. So then third operation is broaching. So it's very simple operation, broaching. So it is even though it is in super finishing operation, but it is not only super finishing, even for basic machining also we can do this broaching. Yes, anybody having any doubt? Any question? So if any question, please let me know. Anybody who is asking me? Yes. Any questions? So no questions. So maybe we can proceed for broaching. So broaching is also a super finishing operation, but not exactly super finishing operation. So broaching is very fast process. With one stroke, complete operation or complete machining can complete in broaching. So machining process for removal of layer of material of desired width and depth. So here normally we used to remove the material more than whatever the microns we have seen previously, two processes. So enable remove the whole material in one stroke with a cutting called as the broach. So maybe this is whatever you've seen. So this is the workpiece and this is the broaching tool. Normally what happens, this broaching tool is reciprocates about its axis, rotating as well as reciprocating. And in this broaching tool, so you used to have different types of teeth are there, cutting teeth are there. So these cutting teeth, so different teeth having different depth of cut. So when you are moving, so when you are moving this, normally this is your workpiece, and you need to move this broaching tool in contact with the workpiece. When it is contacting, so depth of cut in front teeth is high and depth of cut in the back teeth is less. So when it is moving forward, so this is removing more depth of material, but whatever the end teeth are there, so end teeth used to remove very small material thickness. Maybe that is in terms of micron thickness. So tool is slender. So normally we used to use the slender rod kind of tool will be there. Rod or bar type of cutting having a series of cutting edges. So whatever the cutting edges you used to see. So these kind of series of cutting edges are there in broaching machine. So with this series of cutting edges, it's removing the material gradually. maybe if you take, so this is a typical broaching. So broaching tool. So broaching tool is a typical cylindrical or slender type of object is there. So in that maybe you can see some kind of projections are there. So in that projection initially, so initial projections the depth of cut is higher. So as it goes beyond, your depth of cut is decreasing. So what happened here? You see the diameter of the workpiece, diameter of this tool is gradually increasing at the end. So if you see, this is the starting point and this is the ending. So this what happened? You need to keep the broacher in the hole. Normally you used to use the internal holes, even sometimes using for external surfaces also. So what happened? You need to keep your broach tool here, and when you're pushing this side, so this your whatever the tool is there, so this tool gradually increasing the diameter. It's in the slender tool or nothing but your taper tool is there. When you're pushing this, so initially your depth of cut is, even though depth of cut is more, but size of this cutting teeth is smaller. So removing material removal rate in initial teeths are more, but size of the teeth as it's going on, it's increasing. So whatever the material is there in first stroke, it's removing more material. So in second stroke, when in second teeth, whatever is there, it's removing very smaller material compared with this tool. So like this, when it is going to end of this one, so very small material is going to remove. At the come to be end of the tool, end of this teeth, very small material, maybe that is coming in the terms of micron, it is going to remove. That is almost same as your lapping or handing process. So this like this in single stroke, you can finish as well as you can do the super finishing. You can taper, you can remove the material up to the dimension, and as well as you can do the super finishing operations also in the broaching. So broaching is a machining process for removal of a layer of material of desired width and depth, usually in one stroke. So remember, so broaching normally is performed within one stroke. It's completing the operation in one stroke by a slender rod or bar type cutter having a series of cutting edges. Whatever the series of cutting edges, maybe you can see in this. So series of cutting edges with gradually increased proportion as indicated. So series of cutting edges are there. So these cutting edges diameter is gradually increases up to end. So because of gradually increasing in this diameter, so what happened when this is going forward? So each teeth is coming in contact with the newly cut the previously cut the teeth that is in coming in contact, and these later teeth is removing the material lesser thickness than previous teeth. So like this, when it is moving forward, so this teeth, whatever the material is removing, compare with that, this teeth is removing less material. So like this, at the end, it is going to be a super finishing operation is happen. So this process is called as a, so broaching. Normally broaching is using for internal holes as well as the external hole. So this is normally workpiece used to clamp on the fixture, and if it is using for internal holes, maybe this is passing through this internal hole, and if it is external holes, normally for external we used to use to cut the key vases and always any kind of races if is there, to cut those kind of things. Normally we used to use these kind of broaches. So normally for splines, so maybe splines you know, right? So these kind of things, whenever is there, you having a projections, these kind of projections are there. So in these kind of things, normally we used to use these kind of broaching tools. Using broaching tools, so finishing of these spines it very faster. So for external, that is for internal. So normally this is for internal. For external, normally you used to have this kind of broaching tools. So broaching tools used to have a teeth of different dimensions. So these are typical teeth of different dimensions. So as if you move, this is the workpiece. As if it is a move this, if it is move this side. So whenever this, whatever the teeth is coming in contact with the workpiece, it is going to remove the material. So as fronter height of the teeth is smaller than later height, that's why until end you need to remove the material. So in starting, you used to have more removal of material. In end, your removal of material is less. That's why the end process is used to considering as a super finishing process. So broaching machines are generally specified by different kind of specifications. And where is coming to broaching? So broaching is only basic difference in broaching is it used to complete in the single operation. So broaching is not like our shaper or slaughter or maybe in milling, like repeatedly we need to remove the material continuously. It's not like that. With one stroke, so with one stroke, the operation will complete. So in this, maybe if you go for previous slide. So in this slide, if you say, so in this, if you see, so with this is a workpiece, whether internal or external. So if you want to keep your workpiece on this tool, so when this tool is moving, so this whatever the cutting tool is moving, passing through this hole. So initially you used to have cutting. So then you need to have the moderate cutting is taking place, and the end of the tooths. So your finishing operation is taking place. When this tool is moving from this location to this location, your machining will done. So means this is very fast process, and material, because of fast process, within one stroke your process is completed. Normally we not removing very thick material. So removing the material is thickness is less, but compared with honing or lapping, the thickness of this material is comparatively is higher. So this is nothing but, you see, this whatever your broaching tool you see. So this broaching tool is similar to your hacksaw. So whatever the hacksaw you use in your lathe, in your carpentry. In hacksaw, what we used to do, we used to reciprocate continuously. So to cutting this workpiece, what we used to do, we used to reciprocate the hacksaw front and back number of times. Then only you're going to remove the material. But here is not like that. Only once you move from one point to in one forward stroke, so your machining is completed. Remember, it is similar to your saw, but saw used to have very thin slide, but here you used to have very thick surface is there, very area is there. So this area of surface is removing the material. So normally these kind of things are used for external circular surfaces, and this is using for the flat surfaces. The broaching machines are generally specified by horizontal types, whether horizontal broaching or vertical broaching. So this whatever the pushing or pulling is happening. So just give me 1 minute. I'm getting one more call. Some important. Call is disconnected. Okay, okay. So how to specify this broaching machine? So broaching machine normally used to specify by its direction of your broaching rotation. So maybe if you go back to your previous slide, so this can be rotated this horizontally as well as this can rotate in the vertical direction also. So depending upon the rotation, maybe you can specify the broaching machine, so horizontal or vertical, and similarly stroke length. So how long you are broaching, how much long stroke is there in the machine. So stroke length and maximum working force, because here the cutting is completing within one stroke. So that's why you need to apply comparatively little higher force than your lapping and honing. So how much force you are applying, the pulling or pushing. So working force is which direction it is applying, as well as how much force is applying, and maximum cutting velocity can be possible, means how fast you are moving your broacher, and also power rating. So how much capacity of motor is connected to this broaching machine. So these are the few specifications for the broaching machines. So this is a typical broaching machines. Maybe broaching machine, maybe you can see it's look like a lathe. So this is the broaching tool, and here you can keep it your workpiece. So if it is circular, means maybe you can do some kind of internal surfaces, and this whatever things are there. So this is moving in this direction, forward and backward. So you can keep your workpiece here. So on this hole, you need to insert your broaching tool, and when you're moving forward, so from here, if you keep your workpiece here, when you're moving in this direction, once it is passing your tool, so this broaching tool once passed through your workpiece, your machining is done. So there is no again repetition. There is no reciprocating. It's moving backward and then coming forward and moving backward. So until that, you're not required to keep your workpiece. So just you need to move back. So when you're moving this direction, your machining is done. Then you remove the workpiece, bring back. Your machine will come back and keep one more workpiece here, and you can do it. So like this, your broaching process is very fast. So wherever the production rate you want high production rate, so there normally we used to use the broaching. So in broaching, so cutting like your shaper slaughter, or maybe you're drilling, and also you are enlarging the hole like you're tapering or you're boring, whatever you're doing, and as well as super finishing operation. All these three processes are simultaneously is performing. That's why this process is considering as a single stroke process, and it is and because in this in later teeths, whatever the teeths are there, so even it is using for super finishing processes also. That's why this process is considered as a one of the super finishing operations too. But this process is little different than previous two super finishing processes. So this is also typical. This is a horizontal broaching machine, because in this the movement of broaching tool is horizontal. So this is a vertical broaching tool. In this, the movement of broaching tool is in vertical direction. So this is a typical broaching applications of broaching machine. So maybe this kind of internal surfaces, or maybe in terms of external surfaces also you can make. Maybe you can insert a broacher tool. So this broacher tool with single operation, it's completing its process. So these are the few applications of broaching. So these are the three super finishing operations are there. So with this, maybe the major advantages, if you are in the question, maybe in the exam, maybe advantages also may ask you. So advantages and limitations of broaching. So it's a very high production rate. So as I told you, within single stroke, it is completing its cutting process. That's why production rate is very high, much higher than whatever the process you can see, whatever the process till now you studied, whether it's a milling, planing, turning, boring, even for honing. So among all the processes, this process having highest production rate, means very fast the process is completing, and also high dimensional accuracy, because it is one of the super finishing process also there. So your teeth are also provided. That's a high dimensional and form accuracy and surface finish compared with all other conventional machining like milling, turning, drilling, are compared with all, it having high dimensional accuracy, but accuracy is less than whatever the previous two super finishing operation, that is honing and lapping. So roughing and finishing in single stroke of the same cutter. So I told you that's why your production rate is increasing. Within the same stroke, initial teeth are rough cuts, and after that it is a medium cut, and later on it's a finishing cut. So need only one motion. So design, construction, operation, and control are simple. Only one direction when you're moving, your complete cutting process is completing. So extremely suitable and economical for mass production. So obviously, your production rate is very high. Within single operation, you're completing all the cutting process. Then obviously production rate is higher. So because production rate is higher, so these kind of processes are best suits for the mass production. So limitation. So the few limitations also there in this, because every process, when you're having advantages, maybe you're having some kind of disadvantages, and also some kind of limitations are there. So this normally only through holes and surfaces can be machined. So only through holes. If blind holes or maybe partial holes, it's not possible. Only through holes and flat surfaces can be machined by this. Usable only for light cuts. So this, in this, normally broaching is not using for heavy cuts like whatever we are doing in the turning or milling. So there, because it's continuously, we used to have very strong cutting tools are there. So we used to give a very high thickness of material is removing, and very heavy cuts can possible to give. But here cuts are very light cuts, and material removal rate compare with milling, turning, it is less. So cutting speed cannot be higher because single stroke it is completed. This cutting speed, we cannot make it very high speed, because here your finishing operations also involving in it. So normally finishing operations we used to perform moderate speeds. So defects or damages in the broach severely affect the product quality. So obviously, because you're having a single tool is there, so single tool used to cut in single operation. If any kind of damage is happened in broaching tool, so your production quality is completely is changing, and it's maybe it's possible to reject. So design, manufacturing, and restoration of the brochures are difficult and expensive. So initially, because so in whatever the teeth we are providing, so all kind of actions has to provide. So it's comparatively designing of tools. These kind of tools is difficult. So separate brochures has to be procured and used whenever size, shape, and geometry of the job changes. So whenever the size, whenever the shape, or whenever the geometry of the workpiece is changes, you need to have a different broaching tools are required. So like that, you need to have multiple broaching tools. Normally in our other applications, the same cutting milling cutter or the same lathe cutter we are using, whatever the size of the size of the turning we are using. But here, so depending upon the size, depending upon the surface finish, so your broaching, different broaching tools has to use. So you need to use more number of broaching tools. So economic only when the production volume is very large. For small volumes, production volumes, normally this is not economical. The cost of tooling cost itself is going very high. That's why normally for small quantity production, not preferring to go for a broaching. When you're going for very high quantity of production and very fast production rate is required. So high volume of components can be produced in the short time. So in that case, we are normally you're going for a broaching process, except that no other applications. So broaching process can be advisable. So these are the few things are there about the broaching. So I think as per the syllabus, these things are there. So I'm not going to discuss any other things out of the syllabus. So maybe what I will do. So any questions from this up to now about broaching, honing, lapping? So any question? So with this, I can say your third unit, that is milling, grinding, and super finishing operations are completed. So any questions?
Sir, in milling, it's a super finishing process, sir, or just a finishing process?
No. Milling process only cutting process. Milling process is not a super finishing process. So super finishing process only 3 processes, that is honing, lapping, and this broaching. Grinding process also finishing process, but it's not a super finishing process.
Okay.
Remember, milling, turning, grinding, turning, drilling, all these processes are machining processes. Where is the grinding process also considering as a machining process, but actually grinding process is nothing but your finishing process. So once your milling is done, once your turning is done, to make a surface to be smooth, normally we using grinding process for normal application. But some specific applications, normally we are using this lapping and honing for finishing surfaces. That's why these processes called as a super finishing process. So lapping, honing, broaching is considering as a super finishing process. Grinding is considering as a finishing process. And other process, whatever the process we have studied, whether it is a turning, lathe, drilling, boring, shaping, slotting, planing, milling, all these processes are considering as a finishing and nothing but machining process. So only we are removing the material. So even from 10 mm, you need to have 100 mm to reduce for 50 mm. So those machines can possible to do. But these other machines like shapings, these honing and lapping is cannot possible to remove the material more thicker. So normally in one stroke we can use only 3 mm, 3 microns of material only can remove in honing and lapping. So that's why we cannot use for cutting the material. Normally used to finishing the material, we are using this kind of super finishing operation. Any other questions? So any questions? If no questions is there, what we'll do, because my usual practice, we need to go for some questions. So your previous year's questions we can see. We have, yeah, some previous year questions maybe we can see from these topics, grinding and other three. So these are the questions are there from 2019. I've taken few questions from 2019 and few questions from 2018. So these questions from these topics. Milling, already after milling I discussed the previous year's questions. So that's why milling I'm not taking here. So I'm taking about grinding and these super finishing operations. So you see last year 2019 December. So these are the questions writing about the material used for broaching tools. So which kind of material you're using for broaching tools? So normally broaching is nothing but tool only, cutting tool. So cutting tool nothing but whatever the material we're using for cutting tool, that answer has to write here. Normally cutting tool we're using high speed steel, high carbon steel, right? So ceramics, these tools are using. Normally this is using for high carbon steel or maybe high speed steel we are using for broaching material. So this is for 2 marks question, and then last year 3 marks question, define lapping. So just now we discussed lapping is nothing but your finishing utensils, right? Bartana manya ko lapping bolte. So lapping, define the lapping and compare lapping with honing and grinding. So normally lapping is using for flat surfaces, and we are using a abrasive particles, loose abrasive particles are there in lapping. Whereas in honing and grinding, you used to have abrasive particles are mixed with bonding agent, and it has to be in a solid form, right? So there are the difference are there. So maybe you can refer your class notes or maybe refer your textbooks. You can find the differences because it's the 3 marks. First you define the lapping process, and at least 2 differences you can write it for between the lapping and honing. And then one more bigger question for 5 marks in last year's question paper. So what are the various factors to be considered in selection of the grinding wheel? Discuss each in detail. So before class, I think we discussed about the grinding wheel specifications and also what parameters we need to decide. We need to choose while deciding a grinding wheel, which kind of grinding wheel when we're purchasing, what parameters we need to decide, we need to choose. So what are the various factors to be considered in selection of grinding wheel? This we discussed. Maybe you can refer our class video or maybe class notes of before class. So last class we discussed about super finishing operation. Before that maybe we discussed about grinding process. In that maybe you can refer that. So we have discussed about the type of machining, whether the flat, the feature of surface, right? So similarly, grinding wheel, diameter of the grinding wheel, right? So all these things, type of abrasive materials, type of the bonding material. So all these factors is considered by selection of the grinding wheel, and also what kind of workpiece we use to machine. So all these factors is you used to use to selection of any grinding wheel. Similarly, 2018, if you take 2018, there is the 2 questions are there from these 2 topics. So what are the applications of broaching machines? So applications of broaching machines are normally using for external surfaces as well as internal surfaces. So wherever the production rate is higher, there maybe you are using for the broaching operations. So this is for 3 marks. So maybe you can write about a few words about broaching in this kind of question. And next one, the 5 mark questions. What are the types of abrasives? Explain any one of it. So we discussed a few abrasives in our grinding process, right? So natural abrasive and artificial abrasive. In natural abrasive, we have in corundum, we have clay, we have diamonds. So all these things were seen. In similarly in artificial abrasives, aluminum oxide, silica carbide were seen, and also an artificial diamond. So these three we discussed. So write these three names. These three means three in each: natural and artificial. In that artificial abrasives, maybe you can take one, and then you can explain to them. So these are the few questions are there from last year's question paper. So maybe you can refer a few more in that. So maybe a few questions also there in this. So maybe time calculations. So the time calculations maybe we can discuss some other time. So mostly time calculations may not ask you, but in sometimes they may ask you. So this is similar to whatever we were discussed in previous time calculations. Similar kind of concepts will be there. So yes, any further questions from anybody? If no questions, maybe we can stop the class and don't leave the class. I will take your attendance.